Welcome, Wildcats. All right, so in today's video, we're going to be looking at Tuesday, September 20th, solving absolute value functions algebraically, and that's going to be on page 12. So if you would, pause and update your table of contents. All right, now that your table of contents is updated, let's move on to page 12 and look at our notes. All right, so solving absolute values functions. So solving, let's look at the definition. And I want to go back to yesterday's notes, and I want to emphasize that definition of absolute value is the distance from zero. Okay, the distance from zero. Okay, so just like in the video from these notes, I said the absolute value of -2 is 2, and absolute value of 2 is 2, because the distance from zero in both cases is 2 units. One's -2 units, and the other's +2 units, but they're both, if we're just talking about distance, 2 units. Okay, so with that said, the definition of the absolute value function here is that you have x where x is greater than or equal to 0, and you have -x where x is less than or equal to 0. Okay, this is a true piecewise function. Okay, and let's just say x was 5. So 5 absolute value is equal to 5. The absolute value of -5 is 5. That's why we have the x and -x. Okay, so, and we say true piecewise because there's two pieces. Okay, so solving steps. So step one, I'm going to refer back on all examples to these three steps. Step one, isolate the absolute value. Step two, apply definition. And this is the definition, positive and negative. Okay. And then step three, solve. Okay, so pause the video and update your table of contents. All right, now with that said, put your journals aside and let's look at the examples. All right. Now, I'm going to do this video a little differently because Temple's so awesome. They've basically hired for 2 days the inventors of Flipped Classroom. Okay, so I'm going to be training with them on Tuesday and Wednesday to get some more information to make this Flipped Classroom experience even more better than it is. Okay, but I also want to incorporate some of the feedback y'all got. More examples. So since I'm not going to be there, I'm going to go over all the examples like I would in class. Okay, so with that, let's start looking at example number 1. All right, so example number 1. The absolute value is isolated. Okay, so now we move on to apply the definition. And the best way to apply the definition is to draw a line and split into, when you have the positive x and you have the negative x. And really, we have the positive, and I'm going to go and remove the x, but I just want you to know I'm getting it from the definition, and we remove the x here just so you know that whenever we're solving, we have to take into consideration the positive and the negative. Okay? And by doing that, we just put a positive sign in front of this absolute value, and this becomes 3x equals 9. Now, I could write a positive symbol, but we know if there's no negative, that is assumed positive. So this is the positive side. But now here, we're going to put a negative in front of here. Okay? So now whenever you solve absolute value, you have to solve with positive and with negative. Okay? So here, we can see that our first step is to divide both sides by 3. So 3 divided by 3 is 1. And so you get x equals 9 divided by 3, which is 3. Okay? Now, I'm making this video at 4:05, so just so you know, in about 5 minutes, you're going to hear a beep. And so what happens, you might just be warned, and then we'll continue, okay? All right, so I'm going to put a 1 here, okay? So that's negative 1 times 3x is negative 3x equals 9. And then last step is divide both sides by negative 3. So x equals negative 3. Right. And I'm only going to do this for this example, but I'm going to show you how to check and verify that, in fact, by applying a definition, it works for both solutions. Okay. So I'm going to get a separate sheet of paper and just going to do the check here. So all right. So to check, we're going to plug x equals 3 back into function. So that's absolute value of 3 times 3 equal to 9. Well, we know that 3 times 3 is 9, so that's the absolute value of 9 equals 9. And we know that the absolute value of 9 equals 9. So this solution checks. Let's try negative 3. So we check. So then that's the absolute value of 3 times negative 3 equals 9. So 3 times negative 3 is negative 9. So that's the absolute value of negative 9 equals 9. And I apologize for the blurriness for a minute. Just be patient with that. It should focus in just a minute. There we go. I pressed the magic focus button. So I apologize if the math felt a little blurry, because it was. Here, the absolute value of negative 9 is 9. So it checks. Okay. So applying the absolute value definition works because both x equals 3 and x equals negative 3 were solutions. Okay. All right. So what I recommend doing is pausing the video and trying example 2. Then replay the video and see if, in fact, you did it correctly. So step 1, isolate the absolute value. So to do that, we're going to add 1 to both sides. So negative 1 plus 1 is 0. So you get the absolute value of x equals 4. Now, the absolute value is isolated, so now we're going to go to the definition. So we have the positive x, and we have the negative x equals 4. Okay, so here we should see x equals 4 is one solution, so x equals 4. Here we're going to put a 1 in front of the parentheses, and we know that to solve, we're going to divide both sides by negative 1. And so then x equals negative 4. All right, so again, pause the video, try example 3, and actually hold off on the pause. If you did pause, then when you see the unpause, example 3 has a mistake. Example 2 and example 3 are the same. So to get something more out of example 3, let's change this to a plus 1. Okay, now that it's a plus 1, and it's a different problem, and actually we can compare example 2 and 3 and see how they're slightly different. Okay, so pause the video. Now that you've fixed the mistake that I made, let's make that a minus to a plus. Now I want you to try example 3 on your own. And then once you've worked it all out, then play and see if you got example 3 correct. All right, so let's look at example number 3. So here, since it's plus 1, we're going to subtract 1 from both sides. So 1 minus 1 is 0. So you get the absolute value of x equals 3 minus 1 is 2. Now the absolute value is isolated, so we're going to apply the definition. And so I'm going to draw a line separating both sides. So we have the positive side, so that's just the absolute value of x, or the x equals 2, because we're removing the absolute value because now we're just saying we have a positive side and negative side. So now here we have negative x equals 2. All right. So here we just know x equals 2. There's one solution. Now here we're going to put a 1 in front, so that's negative 1. And we're going to divide both sides by negative 1. And so then negative 1 divided by negative 1 is 1. So you get x equals negative 2. All right, so pause the video again. I want you to try example number 4. And then I want you to replay it and you can check your work. All right, so example number 4. We're going to isolate the absolute value, so we're going to divide 3 by both sides. So 3 divided by 3 is 1. So you get the absolute value of x plus 1 equals 1. If you would, I'm recording right after school, so I have someone at the door. So I'm going to answer the door, answer the question, and I'm going to come right back. All right. Apologize for the delay. I'm back. All right. So let's look at this. So, all right. So here we've isolated the absolute value. So now we move on to step 2. And then we apply the definition. So we have a positive side and negative side. So that's positive x plus 1 equals 1. And we have a negative. Make sure the negative's outside of the parentheses. X plus 1 equals 1. And the negative's always outside the parentheses. Okay? So then here, now we've applied definition. Now we solve. Here, you can see we really don't need, parentheses can be removed. And so here, the only step here is we subtract 1 from both sides. So x equals 0. Okay? Now here, we need to put a 1 in front, and now we need to distribute or multiply the negative 1 times the x and the 1. So negative 1 times x is negative 1x, and then negative 1 times 1 is a negative 1 equals 1. All right, and then the next step, we're going to add 1 to both sides. So negative 1 plus 1 is 0. And you get negative 1x equals 2. And the last step is we're going to divide both sides by negative 1. And I've ran out of space, so I'm going to keep all my work in this box. I'm going to draw a little arrow, and we know that x equals negative 2. So there's your 2 solutions. All right, so again, pause the video and try example 5. And then once you worked it, then play the video and see if you did the work correct. All right, let's look at example number 5. All right, so first step, isolate the variable. So we're going to, or I should say, isolate the absolute value, okay? I misspoke in that. isolate the absolute value. So subtract 3 from both sides. So 3 minus 3 is 0. So you get absolute value of x minus 1 equals 3 minus 3 is 0. Now, the absolute value is isolated. We're going to apply the definition. So we have a positive side, so positive x minus 1 equals 0, and a negative absolute value, or parentheses x minus 1 equals 0. The parentheses go away because we're applying the positive and negative. So I haven't said it in any of the previous examples, but the absolute values go away because we're applying the definition, so we're applying positive side and negative side. So on the left side, you can see the parentheses, we don't need them anymore. So we're going to add 1 to both sides, and so then x equals 1. Okay? Now here we need to put a 1 in front of the parentheses, and we need to multiply that negative 1 by both terms. So negative 1 times x is negative 1x, and then negative 1 times negative 1 is a positive 1 equals 0. And then the next step is we're going to subtract 1 from both sides. 1 minus 1 is 0. You get negative 1x equals negative 1. Okay? And then you're going to divide both sides by negative 1. And so then x equals 1. So your solutions are x equals 1, x equals 1. So in this case, the solutions are both 1, so we could say it has one solution of x equals 1. So it's great that example 5 is in there because example 1 had 2 solutions, example 2 had 2 solutions, example 3 had 2 solutions, example 4 had 2 solutions, and example 5 had 1 solution. All right, so pause the video again, and let's look at example 6. All right, so we're going to put a 1 in front of the absolute value. It's a little hard to see, so I'm going to make it bigger. But we know that to isolate the absolute value, we need to divide both sides by negative 1. And then we know anything divided by itself is 1. So negative 1 divided by negative 1 is 1. So you have the absolute value of x plus 1 equals negative 3. All right, so now we isolated the absolute value. We're going to apply the definition. So here we have a positive parentheses x plus 1 equals negative 3. And we have a negative x plus 1, parentheses x plus 1 equals negative 3. Okay, so here we can see that we don't need the parentheses anymore, and we can just subtract 1 from both sides. So x equals negative 4. Now we need to put a 1 in front of the parentheses and distribute or multiply. Negative 1 times x is negative 1x. Negative 1 times 1 is a negative 1 equals negative 3. We're going to add 1 to both sides to get negative 1x equals negative 2. And then divide both sides by negative 1. So x equals 2. All right, now that concludes the examples. Now remember, this is on page 12, so there's going to be 2 page 12s. So put a 12 here, tear that page off, and hole punch it and put it in your journal. All right, now because I'm not here on Tuesday, I'm not here on Wednesday, I'm going to make this assignment due on Friday. So write this down, Friday, September Make sure I get that right, 23rd. So I'm going to give you an extension for this assignment, Friday, September 23rd.